Arithmetic Sequences, Lesson 2 series. This lesson will focus on deriving a rule for determining the sum of an arithmetic series, of determining values of T1, D, N, or Sn, and solving problems that involve arithmetic series. An arithmetic series is a sum of terms that form an arithmetic sequence. Each successive term is added until the last term. So in the series 2, 4, 6, 8, S4 is the sum of the first 4 terms. We can use a formula to find the sum of a general arithmetic series. So Sn, or the sum, is equal to n divided by 2 times T1 plus Tn, where n is the number of terms, T1 is the first term, and Tn is the last term. Sometimes we don't know the last term of the series and we want to find the sum of. So example 1, a particular firefly flashes twice in the first minute, 4 times in the second minute, and 6 times in the third minute. So if we look at this right now is set up as a sequence with a common difference of 2. 2 plus 2 is 4, 4 plus 2 is 6. If this pattern continues, what is the number of flashes in the 30th minute? So I want to know, if I go 30 steps down the road, how many times will it flash? In that case, n would be 30. T1 is 2, and my common difference is also 2. So substituting into our Tn formula from the other day, Tn is equal to T1 plus n minus 1 times D. Tn is what I'm looking for, how many times it flashes in the 30th step. So T1 is 2 plus n is 30 minus 1 times 2. So T30 is 2 plus 29 times 2. 29 times 2 is 58, plus 2 is 60. So T30 is 60 times. So in the 30th minute, that little firefly is going to flash 60 times. Part B says, what is the total number of times that it's flashed in 30 minutes? So this time what we want to do is we want to continually add up those numbers until our last term is 30. So we're going to use our sum formula. The sum formula, so the sum of the first 30 terms, is equal to n over 2 times the first term plus the last term. So the number of terms this time is 30. I set up my series sequence wrong here. It doesn't flash 30 times in the 30th minute. It flashes 60 times. Back to our formula. Number of minutes is 30 divided by 2. First term is 2. The last term is 60. Solving. 30 divided by 2 is 15 times 2 plus 60 is 62. So that firefly flashes 930 times in 30 minutes. We know that the last term in a series or sequence of n terms is Tn. We can then combine the two formulas that we have, so this one and this one, and come up with the equation that Sn is equal to n over 2 times 2 times T1 plus n minus 1 times D. That formula is arrived at by substituting in this part of the expression into here for Tn. We can use this formula as a shortcut to finding the last term and then summing, because it does all of that in one step. So in the last question we had to find our Tn first, so we had to do this step, and then we substituted into here. If we would have had this equation, we could have just substituted directly in there. So we use the first equation when we know the first and last terms, and the second sum equation when we don't know the last term. Find the sum of 80 plus 75 plus 70 plus 65, up to the 33rd term. So in this question, we don't know what that 33rd term is. And so we're going to use the equation, our new one, that Sn is equal to n over 2 times 2 times t1 plus n minus 1 times d. N is 33, so I have 33 over 2 times 2 times 80 is t1 plus my number of terms is 33 minus 1. D in this case, what's happening to go from the first term to the second one? We are subtracting 5. So D is negative 5. So we end up with 33 over 2 times 2 times 80 is 160 plus 33 minus 1 is 32 times negative 5. So 33 over 2 times 160. 32 times negative 5 is minus 160. That means that this is 0, and anything times 0 is 0. So it turns out that when we add up those 33 terms, we're going to end up with a sum of 0. The sum of the first two terms of an arithmetic sequence is 13. And the sum of the first four, so let's write this down. The sum of the first two is 13. The sum of the first four is 46. Determine the first 6 terms of the series and the sum to 6 terms. This problem involves using solving systems of equations, which we've already covered. So let's write a formula for the sum of the first 2 terms. The sum of the first 2 terms is equal to n over 2, so 2 over 2, times 2 times t1, I don't know what t1 is, plus n minus 1, so 2 minus 1, times d. And again, I don't know what that common difference is. The sum of the first 4 terms is equal to n over 2, so 4 over 2, times 2 times t1, plus 4 minus 1 times d. Okay, go back to my sum of the first 2 terms. I know that the sum of the first 2 terms is 13. So I have 13 equals, 2 divided by 2 is 1, so this part will just disappear. And I have 2 t1 plus 2 minus 1 is 1, so it becomes plus d. So there's my first equation. My second equation is going to come from the fact that the sum of the first 4, sum of the first 4 we know is 46. So I have 46 equals 4 divided by 2 is 2. And then my brackets simplify to be 4 minus 1 is 3d. I can distribute my 2 in, and I end up with 46 is equal to 4 times t1 plus 6 times d. I can simplify that equation a little bit more because each of those terms is divisible by 2. And so 23 equals 2 t1 plus 3d is going to be my second equation. Going to rewrite it over here underneath equation number 1. So I have 23 equals 2 times t1 plus 3d. Remember that I want to line up my terms. Because both equations have 2 times t1, if I subtract, I will eliminate my variable t. So 13 minus 23 is negative 10. My t's disappear, and d minus 3d is negative 2d. Divide both sides by negative 2, and I end up with d being equal to 5. I need to find, so this is my common difference. I also need to find my first term, and I can find that by substituting back into equation number 1. So I have 13 equals 2 times T1 plus D, and D we have found to be 5. Subtract 5 from both sides, and I have 8 equals 2 times T1, so therefore T1 is equal to 4. The question asked me to write out the first 6, so my first term is 4. To get the second term, I need to add 5. I get 9. Add 5 again is 14, 19, 24, and 29. So this is written as a sequence. As a series, would be plus signs in between. And we're asked to find the sum of those numbers. So the sum of the first 6 is equal to n over 2 times T1 plus T6 in this case. So my sum is equal to 6 over 2 times T1 is 4 plus T6 we found to be 29. So the sum of the first 6 is equal to 3 times 33. 3 times 33 is 99.